live on Facebook. So George, let us know when that starts. Yeah. Refer to George.
We're live.
Okay, so go ahead, Al, take it away.
Okay. Good evening, everyone. Thank you for coming. We are in the midst of a renaissance of exploration as far as spacecraft are concerned, proposed probes to other planets, going to Mars, many other things all at once, which is wonderful. Because I'll be honest with you, in the early 70s, it didn't look like we were going to have very much of a program at all. Luckily, things have worked out right. We know more about the solar system today than we have in literally the history of humanity, and we're still learning. But this is a talk of something which we learned about because of the exploration, about our own world, maybe something of the human condition as well. This is going to be a story of exploration, the pale blue dot. And I guess you've already imagined, you already know what this is. This is us. That is the moon. And we'll be talking about how this picture was taken, and many others have followed. So, okay, in the late 1970s, NASA's Voyager program sent 2 spacecraft to the outer solar system in the first exploration of the gas giant planets beyond the orbit of Mars. And by the way, we have 2 of them in the sky right now. Saturn over here, and still rising in about opposition, where it's best lit up, closest to Earth, and bright, Jupiter. Okay? And this is, of course, beyond the orbit of Mars. This took advantage of a once in a 176 years alignment of the outer planets. No, we're not talking astrology. This is the real thing over here. They do move about relative to each other and to Earth. Okay, there were 2 identical spacecraft. This is just an overview and such. This is the basic bus that they attached all the equipment to. Cosmic ray detectors, ultraviolet spectrometer, imaging equipment, low energy charged particles to see magnetic fields. It was powered by radioisotope thermoelectric generators. They had 3 of them per vehicle. They generated heat from the literal fission of radioactive materials such as plutonium. So once this was away from Earth, it was gone. And by the way, it was not bomb quality either. It would not, if some, God forbid something happened, it would crash. If it crashed, it would not go up like an atomic weapon. This is not the right kind of fuel for it. It also had an optical calibration spectrometer, a photopolarimeter, so it could measure light very precisely. And the bus itself has the electronics, basically the brains of the equipment. Okay, so 2 spacecraft, 2 destinies. Voyager 1 went out to Jupiter, Saturn, and there's a moon of Saturn, its brightest one. It's also its largest, called Titan, which has an atmosphere. And we knew that it was there from ground-based observations. We just didn't get any really good close-ups on it. Voyager 2, however, did what was called the Grand Tour, that once in 176 years. Jupiter, Saturn, Uranus, and Neptune, and parts well beyond. Okay, after launch, September 6th of 1977, Voyager 1 looks back at the Earth-Moon system. This is how we would appear if you were in a spacecraft, starship, whatever, and you're approaching Earth. Distance, I believe, on this was just under 500,000 miles. Okay, a little less than 2 years later, March 5th, 1979, the first port of call for both of them, of course, both vehicles. Jupiter's flyby. Nice shot here where they took actual photographs taken by the spacecraft. 2 of the moons, Io and Europa, the spacecraft put on it. It's pretty much how it probably would have looked if you could have stood out there. And then 1990, November 9th. Gee, we just passed that day. So we have an anniversary there. Saturn encounter. Of course, this is the artist's conception. This is the real thing. They're looking down on the planet. There was a reason for it. They wanted to go to a moon I mentioned before called Titan. And it's a good possibility there might be, maybe not life there, but at least the chemicals that eventually would form life. That's the reason why we sacrificed 1 spacecraft. It was that important. And speaking up and up to Titan, this is how Titan looks from a spacecraft point of view. And very close in, you can see the layering of the titanium atmosphere. The atmosphere is mostly nitrogen, it turns out, at about roughly around 340, 350 degrees below 0 Fahrenheit. And yet even here, you'll still find what appears for all the world of lakes filled with liquefied nitrogen and other organic chemicals. So it's a very interesting place. There may not be life there, but at least the chemicals for it are there. Okay, so Voyager 2 sent to a multi-world tour from Saturn on to Uranus in 1986, then Neptune in 1989. Voyager 1, however, continued flying from the solar system and far above the ecliptic, which is the plane of the paths, actually of Earth, but of the planets, more or less. But what could this flight tell us beyond the exploration of new space? So a look back was possible. This is a computer-generated image showing the Voyager vehicle looking back to the solar system. It had its limitations. The sun, of course, blinded the spacecraft to be able to see Mercury, so that was out. Pluto was way too faint. Talk about two contrasts. Talk about two contrasts. And Mars was just in the wrong place at the wrong time, too close to the sun. Kind of a shame that. So for the first time, we could photograph our solar system as worlds in orbit around our sun. Astronomer Carl Sagan, anybody ever hear of him? Oh yeah, a couple people. Okay, saw the possibilities and pressed for NASA to perform the experiment in 1990. So on February 13th of 1990, Voyager 1 warmed up its cameras for 3 hours. You got to remember, this thing is all the way past Neptune and looking back. The temperature out there is approximately 400 below Fahrenheit. So they had to bring the cameras up online and warm them up. Then the spacecraft science platform was pointed at Neptune and they started the session. After Neptune, it took images of Uranus, Saturn, the sun, kind of a picture, a bright blur. Then Jupiter, Earth, and Venus. Mars, as I mentioned before, and Mercury were too close to the sun, and Pluto was too faint to image. Okay, the Earth images, now this is great, were taken at 4:48 Greenwich Mean Time on February 14th, Valentine's Day, 1990, 34 minutes before Voyager 1 powered off its cameras forever. It took until May 1st, 1990, and 4 separate communications passes with NASA's Deep Space Network for all the image data to finally get back here to Earth. Voyager 1 had captured the images of 6 of the 7 planets targeted, as well as the sun. So here's your family portrait. As I mentioned, with the exception of Mercury, Mars, and Pluto, the rest of the solar system was imaged on February 14th, 1990. And some of these are just tiny combinations, a couple pixels worth. Okay, and this is us. 3.7 billion miles out. February 14th, 1990, from Voyager 1. This is you. This is us. If you were alive at this time, you were in that picture. Congratulations. You share the copyright. Oh, yeah. And so we have to buy?
Not yet.
Okay.
Not until the end.
Okay. Okay, good. Now, where are they now kind of stuff over here? Still operating. On August 25th, 2012, Voyager 1 went interstellar, past the heliopause, the area where the influence of the sun faded out, and then you're in interstellar space. So it's a nice shadow. I picked this up. This is not a real star background, but it gets the point across. A little vehicle just heading out. So where are they going? Good question. Voyager 1 is escaping the solar system at a speed of about 3.5 astronomical units, somewhere in the order of about 340 million miles per year. It's 35 degrees out of the ecliptic plane, the orbit actually of Earth, to its north in the general direction of what's called the solar apex. That's an area where it appears that the sun's relative motion is heading toward to nearby stars. Voyager 1 left the solar system, headed out toward the constellation of Ophiuchus. That's a summer, a summer constellation. And if you got the time, kick back, in the year 40,272 AD, probably sometime in March, Voyager 1 will come within 1.7 light years of a star in the constellation of Ursa Major, the Little Dipper. And this is a catalog number, AC plus 793888. 79 degrees north declination, 388.8 in what we call right ascension. Voyager 2 is escaping the solar system at a speed of about 3.1 AU per year, 48 degrees out of the ecliptic, going to the south toward the constellations in the summer of Sagittarius and Pavo, a southern constellation called the Peacock. In about 40,000 years, again, you got a lot of time, you kick back, watch. Voyager 2 will come about 1.7 light years of a star called Ross 248 in the constellation of Andromeda. Okay. Based on the Pioneer 10 and 11 plaques, that are both very, very ambitious, very crazy, and also just a tiny bit risque here and there. Both Voyagers have these records attached to the main bus. The cover explains what's needed to read the data, and if it is done correctly, what the first image will look like. If you get it right to the aliens, whoever it is, the first image should be a perfect circle. And this explains how to make it work. We assume that if you have spacefaring beings out there, they will probably figure this one out and be able to come up with the imagery and the writing and such and recorded sounds that are on the record. A stylus similar to a record player's needle. Anybody remember record players? Yeah, well, that was the tech at the time. Is included in the package, which I think is very nice of them, as well as a map of pulsars, which is down here. In binary, it says what their period was when the vehicle, see, a pulsar is a collapsed star, a neutron star, and it spins around hundreds if not thousands of times per second, generating radio waves of pulses, very, very regularly spaced. Now, they do slow down over a period, hundreds if not thousands of years, after the supernova that created them has long gone. But you can look at these destinations relative to where we are and they would get an idea approximately when this thing was left in their time. And who knows, we'll get a visit 50,000, 60,000 years from now if we don't go there first. And of course, information about the record tells of Earth, life here, and of human civilization, such as it is. Okay, and here we are on the Voyager, I think this is Voyager 2, where they had attached the records. See, it's all white room. Of course, this guy's not wearing a mask over here, but who knows? And they were getting ready to have this for liftoff and launch. And here's a copy of it. One of only 3. Now, the sounds and such of Earth were actually recorded and I think they're still available for sale, called The Sounds of Earth, the Voyager record. It's on DVD now. Okay. This is a very, very old technology over here, unfortunately. But the copy of it is on display at Washington Dulles Airport. They only NASA officially created only 3 of these records. So this is the only one and only we have on Earth of its type and such. Oh, yeah. There's a terrific book. I recommend it very highly, dealing with interstellar communication, the making of the record, everything, how the pictures were selected, the actual pictures that were sent, everything on this book, Murmurs of Earth. It's co-written by Carl Sagan, Tim Ferriss, a number of other people. Yeah. Any thought? You'll forgive me, ladies and gentlemen. I just had a birthday, and I ain't getting any younger. And I'm waiting for something to happen that just might change the world a little bit, so maybe we'll survive into the century after this one. So far, I'm not getting very, very much fun from that. So it's very emotional to me. Okay. I have to thank Bonnie, who has held this thing together. Mary Duca, who allows me to give these talks. Acid JPL, who created this whole thing. And I have to thank Carl. We lost him back in '96. And that is him standing in front of a mock-up, a full-size mock-up of one of the Voyagers. Think about this here. The nitrogen in our DNA, calcium in our teeth, the iron in our blood, the carbon in our apple pies were made from the interiors of collapsing stars. We are made of star stuff. Carl Sagan. And unfortunately, humans have a tendency to age and unfortunately die. This I only heard just recently. It just occurred. Ken Mattingly, grounded by measles, of all things. He worked to save the crew of Apollo 13. He basically, if you look in the movie, that he is represented there by a gentleman named Ken who's going to hold everything together. And the idea is he's in a simulator and he's constantly trying to get the amount of power so that the amount that goes in would not surge and maybe wipe out the electronics or destroy the battery or combination thereof at Apollo 13. And he said it right. You guys, you want to take a break? And he says, they don't get a break, I don't get one. That's a direct quote, by the way, from him. And this is what he did. He saved the crew of Apollo 13. He became command module pilot. After all, he knew the command module, up, down, right, left, for Apollo 16. And he later flew Space Shuttle mission STS-4 in June of '82. That's him. And I just found this out. This just occurred. Frank Borman was 95 when he passed away. He was on Gemini 7, which I thought was pretty cool. Because 6 and 7 of that program did a beautiful job. They rendezvoused. They came within a foot of each other in the Gemini 6 and 7 spacecraft. And of course, the Army-Navy game was on there. So one of the spacecraft went by and held up a sign saying, Army beat Navy. One orbit later or so, Navy beat Army. So, they always had these friendly and sometimes not so friendly rivalries. But the cool thing about it was that he went on Apollo 8. And for years, he swore that he was the one that took this picture, which is called Earthrise now. This is the way it was actually photographed. You've probably already seen it where it looks like the Earth is rising over the moon. The reality is that you're coming around the back here of the moon, and there's the Earth. That's us. And this is the close encounter. They came at a foot of each other, Gemini 6 and 7, proving that humans could rendezvous and do it repeatedly. Very important if you're trying to get to the moon. Okay. Now, are we ready here, Bon? Or we have to
Try it again.
Okay. So let's try down here.
Right click.
Okay.
All right.
Oh, we gotta go past
Welcome back to Wawa Syntopia,
Sorry,
your
folks.
handcrafted beverage happy plate.
From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they can become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. our postures, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lone speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
So my wife got me this weird new.
Oh, well. No, that's an example of our civilization, too. And I think that's it. Yep. Okay. Stream still. Don't have any more. Let's see something.
Yeah, I
There.
do.
Are
Okay.
any of the Voyagers relaying?
Oh, there we
information
are.
back?
We're not quite done yet. I don't believe. No. Yeah, we did. It's okay. A little out of order there. Okay. Okay. All right. So are there any questions?
Are any of the Voyagers relaying any information, or they're just kind of out?
Voyager, I believe Voyager 2 is still active. It's got 3 experiments that don't consume very much power. We will lose apparently contact with them, lack power, around the year 2032, last time I heard. And basically, it's just giving us tasting the stellar wind that's around there. It's well past the influence of the sun. So whatever hits it is out there, well beyond us. Any other questions?
Yeah, I'll have one. Do you know the picture that shows the pale blue dot and like a streak?
Yeah.
Like, do you know what that streak is? Like
That's a scatter coming off of actually one of the green filters. There are red, blue, and green filters aboard as well as infrared. But that's basically scattered light. That's how close. Remember, we're 93 million miles away from the sun. We're all the way back out here with the spacecraft, about 3.8 billion miles away. So we had to look very close in. That's why we couldn't see Mercury, way too close in, and it turned out Mars was on the far end of the sun at that time. So we couldn't image it. And Pluto was way too faint for cameras. So we got lucky we got what we got.
so that like it sits like in that streak of light. You're saying that's scattered.
That's it. That's scattered sunlight. That's right. Probably somebody didn't clean one of maybe the green filter, I would say, correctly.
We can go and get that slide.
Try doing that. Just here we go. This one.
Yeah.
That's it. That's us. And again, that streak, it is. Yeah, it's probably one of the filters you can see. There are more streaks here too. Just happen to be where we are. That is a bit of a humbling concept when you think about it. At that time, roughly, I think in 1990, roughly about 5.25 billion people or so on Earth. Probably obscure. So it is a humbling thing to think about. And a little bit more dust on the camera, and maybe we wouldn't have gotten that picture. So we were kind of lucky over here. Okay. There's a hand in the back there.
Yeah, in the back.
Do you know if there's gonna be any more exploration of Titan anytime soon?
Any more explanation?
Exploration of Titan?
There are plans to start a Titan surface lander. Cassini was the only one so far that went into orbit around Saturn, of course, but it also dropped the probe, if you're aware. There's enough ethane and methane there liquefied so we can probably power the civilization here for 1,000 years or more. But what we're more interested in is the fact that the chemicals of life are there too. And right now, we don't have anything set like expression set in frozen rock. Eventually, we'll probably get out here. Maybe, I'm going to be optimistic about 2030s, late 2030s. It takes a while to get out there. Hopefully, by that time, somebody will come up with not an ion drive. They're not science fiction. They're real. But we might come up with something much more efficient so we can get out there. There's an idea. Just when you meet NASA somewhere, there is a plan afoot to try to build a rocket, which is a nuclear rocket, which will take 10 days to get to Mars. Yeah. So we got something like that behind it. It's about maybe 9 months, a year to get up to Saturn space. And it's, don't say it too loud, because people scream when you hear it. Nuclear power. But it's not the kind of thing you make a bomb out of, okay? But let's get that clear. Not everything that deals with nuclear reactors creates bomb material. But in this case, it's lots of power. And it would get us, as I said, one plan was to get to Mars in 10 days. So that's my kind of short. This 3-year thing killed you after a while. But seriously though, right now there are no definite plans, but people want to build it. I've heard of a helicopter similar to what they put on Mars, but here it doesn't need these big super wings. There's such a dense atmosphere. Our atmosphere, one atmosphere here on sea level is what, 21 pounds per square inch. On Titan, when you proportion it, it's about 1.5 times the density of our atmosphere here, which means maybe you want to hold onto your hat when the wind blows, because they'll try throwing you into the air rather than flying. Now, wouldn't that be cool? It flies over, photographs the area, circles around, lands, takes a sample, seals it up, picks up, and goes again. Keeps on going, then we could bring it back to a surface lander, put it in there, seal it up, fire it off to a waiting spacecraft, and get it home. Now, that would be incredible, and I hope I live long enough to see it, because it would be amazing, especially if there's any life in it. Now, we ain't the only masters of life forms and carbon and such. Who knows? Any other questions?
Could the moon be like have like the scattered rays? No, like could the moon be enlightened with a scattered ray?
Could be enlightened with the scattered rays of the material.
I don't quite get it. You could, we do have a vehicle that I think that tried to work and didn't make it, which was called lunar flashlight. It was a laser that would light up here so you can see. As far as finding anything in here, it's all speculation. We don't know. That's why what exploration is. Go up, maybe you will in 20 years, 25 years, might be up there. Yeah, call my name on the rocks. And I hope you do it. I really do. I just had a birthday. Carl, if he was alive, would be 20 years older than I am right now. Yeah, I'm 69. Ouch. Okay, so I'm hoping to live long enough to see at least, I hope, the first boot print on the surface of Mars. And she will be a hero like you wouldn't believe it. So, hey, this isn't a boys' club anymore. It should never have been. So who knows? The future is still open. The future is still bright. Despite all the troubles and horrible stuff here on Earth, we can still do this work. And that means that there's some kind of, I don't know, some kind of glory in all of us. Not religious, just the concept of right and wrong. And that, I think, is going to save the day. That's going to make the day. The people will finally rise up, stop the baloney that's happening around the world, not just here, not just in certain other countries. Everybody suddenly realizes they have a purpose and a reason for existing, which we all do.
Now, don't forget to ask the people online if they have any questions.
Okay, anybody online want to ask a question?
Well, I don't really have a question. This maybe just a comment that Carl Sagan, as we were talking about him, he was instrumental in creating these records that were on the Voyager and
That's right.
Explorer spacecraft. And that he actually graduated from Roy High School.
Excellent. How about that? I would say that if you want to find the full story of the Voyager record, it's a book called Murmurs of Earth. I think we have it in the library here too. If you remember, you can borrow it, which has the whole story. You're absolutely right. Thank you, Charlie. And I think you can still get copies of it brand new, or go to a used bookstore, get on 8. Revealing one of my great deep secrets of finding books, but no one else can usually. ABEbooks.com. If they ain't got it, it ain't. They have 15,000 booksellers around North and South, part of South America and into Europe. I tried to find a book, for example, on lunar mineralogy. Came back about 1974 or so, thereabouts. It's done in the style, if you're familiar with geology, the style of Dana's, where it breaks up from native metals, oxides, carbonates, silicates, stuff like that. The same thing that was done on a far less grander scale for the moon. I couldn't find a copy of it. Jay Wiley's done this. It's been out of print better part of 15 years, more. So I went on abooks.com just for the fun of it. Bang, I found it in West Germany. Well, now, back then it was West Germany. And I found it in Germany. They sent the thing to me inside 3 weeks. It was fantastic. So it's right next to my Dana's with Earth rocks, right next to it with Moon. I hope to have another one from Mars. See what happens. Any other people out there in the great cyber universe?
That was a good talk, Al.
Thank you. I try. Hey, Mary, I guess
Thanks,
you're.
Al. Thanks very much. And just
And thank Bonnie for your help.
Just a reminder that next week, we'll be up at the main campus at the Roy Smith Theater for a monthly meeting starting at 8 o'clock. But then the following week, it'll be the Friday after Thanksgiving, we will be open and we will have another presentation then, okay? And also, don't forget, taking home these brochures. We just found out last night the brochure, the monthly meetings of our speakers. The March and April speakers have switched. So the April speaker is speaking in March speaker is speaking in April, okay? All right, thank you, everybody. Thank you, Al. Great.
Thank you. Thank all of you. Good evening.
Thank you.